You're right. Fabulous. Great. So let's get started. Thank you very much for coming to basically this workshop. Today we'll talk about this engineering for one planet framework. We'll do some activities together to be able to see how we can basically integrate some of the learning elements in this, and also get introduced to Grace and Berlin and their great resources on our campus. And we look forward to also enrich our educational contents, specifically the ones that are related to sustainability, with the projects that are ongoing in Grace basic office as well. So, and also we've got food in the other room. There's ample food, so we'll go there after 30 minutes or 40 minutes, so do not worry at all. We'll take good care of you. And I would also like to thank Samir. He has been a great support for this project as well. And it's been since 2022 that we've been involved with this engineering for one planet framework. But let's get started and basically see what's this EOP framework is about, talk about the workshop structure, and also make some introductions, get familiar with each other, and then we'll go for basically the first break, and then we'll continue from there. So what is this EOP framework? Let's take a look and see how the Lemelson Foundation basically introduces this in their own words. And of course, the whole gist of this EOP is they want to basically not create, but educate engineers in environmental and social sustainability so that they fulfill their duties as engineers towards these important goals. So let's get started. Interesting. It was more working in the morning, but
check the basic volume in the others.
yes.
It's the volume on the TV.
I think maybe try the speakers and then press play. Speaker comes on.
Oh, okay.
It usually blinks when you click on the thing, right? That's whatever. Okay.
Okay, so then let's see if we can.
No, that's it.
Sustainability is a concept for a different model of how we meet a material reality. That allows us not just to enjoy the present, but also to be something for future generations to come.
Every decision that we make ultimately has this ripple effect. We have to change the way that we think about the world. We have to change the way that we define things in the world.
So I hear some engineers who make the things that we use to live by. And so I think it's about embedding that with sustainability with engineering so that it's ultimately synonymous. Want to learn more about sustainability. They want to understand how we can possibly address climate change.
Engineering for One Planet has a vision that sustainability will be a core tenet of the profession. So we're working to transform engineering education to equip all students with skill sets and mindsets to ensure that engineers are able to protect and improve our planet and our lives.
I think sustainability challenges. Sure. And STEM practice really wants to do that. I prepare engineers for the professional world, and it is important that they are ready for the challenges so that society becomes in the stage for them. We are huge all vision development time. Engineering for One Planet is transformative. Really imperative for schools school, everyone really that have a voice and an interest. So students are key, administrators, professors, but it's also very key to have industry there to showcase that there is a workforce needed for this as well.
I think increasingly we're seeing industry have demand for engineers who are specifically working in the area of sustainability. But we also recognize that so we need everybody thinking about those kinds of design decisions for the sustainability mindset.
And EOP, I forgot the last one, I said, concept of sustainable issues, criteria. I said, students are exposed to programs.
Framework gives institutions full back efforts, roadmap. Start to see basic transformation.
Design, engineering something is an innately hopeful and optimistic endeavor. There is true power in enough people to actually come into the table, and these are the tangible ways that we can change it. It's that engineering for one planet isn't just about changing courses, it's about changing the course of engineering.
I believe that in the future, what we call sustainable is just going to be.
Wonderful. Okay, so, but of course, it's just the motivation, and we'll see what are the elements that they want to get engineers basically educated in. And Samir, everybody of us who are in engineering, there's also the foundational accreditation criteria, which is the ABET. Because if university requires the accreditation, they should also be accredited in ABET, and they have created a very nice one-to-one mapping between the ABET outcomes and the EOP framework. And the goal is, of course, to make sure that the faculty can do this integration with the minimal amount of work. Okay, so basically the EOP definition is a comprehensive guide designed to integrate sustainability-focused learning outcomes into engineering education. And the purpose is, of course, to equip engineers with the necessary skills and knowledge to address environmental and societal challenges. So we will see that one of the things that this EOP framework integrates is also the elements of social responsibility for the engineers, which is something that, I mean, traditionally, engineers were not being trained on. It was only the technical skills. You do the technical job, don't worry about the rest.
I was gonna add kind of on the video on here too.
Yes.
Basically, it's not necessarily engineers working on sustainability problems, but any engineer working on, battery technology. When they're in those meetings in industry, they should hopefully think about the source of lithium and the
Yes.
disposal process, right? Those sustainability issues should become requirements in any engineering projects, right? Not necessarily working on climate change or working on whatever it's.
Sure.
Basically, it should cover everything, right?
Yes.
And then something that came up in our meetings with them is the idea of tipping point. So the idea is to infuse these ideas in enough courses throughout the semester, throughout the curriculum, that it just becomes culture. It's like, yeah, of course, when we design something, we should think about the sustainability of that solution. Right? So we're starting with 4 courses, right? But then eventually, if enough classes talk about this stuff, it just becomes culture. That's kind of the hope. With the most foundations.
And of course, the need is clear. Engineers play a critical role in shaping our world. Actually, you wouldn't have any worlds if there were no engineers, in a sense, because you're living in a technical world. Incorporating, of course, sustainability ensures responsible and forward-thinking design and innovation. And the impact is, of course, sustainability engineering can significantly reduce the environmental impact while enhancing societal well-being. And of course, there's a huge, there's a history behind this. The Lemelson Foundation was basically you can say the Kickstarter of this movement, and they were the main backers. And basically, they started this endeavor back in 2017.
So the EOP, right?
The EOP.
The Lemelson's older, I think.
Lemelson is much older, but they started working on this back in 2017. And then they developed the very first draft back in the 2020. And I mean, in order to start the process of basically branching into different campuses in the US, they initiated this mini grant program. And actually, it was the way that Samir and I learned about this back in 2022. And of course, now they're doing even more, I mean, greater initiatives, and they're doing the NSF. And Delian, actually, I think that you were the PI of the proposal that you submitted. Now, it shows how they are basically scaling up from the mini grants to some institutionalization, just administered by the Lemelson Foundation. Now they're basically in the NSF area. And of course, they have made the revisions in 2022, and we'll go over, but this is just a very brief introduction. Now, of course, we have got all these great faculty members and colleagues here. We have an expert in basically sustainability, so we don't claim that we are experts. And of course, we will be more than happy to basically get introduced to what you do and the things that you do in your office. We've got faculty members across the campus, and Samir and I, of course, are facilitators of this workshop. And we've got Delian from IMSC, Azim from ECE. Dr. Sholi wouldn't be able to join us. IMSC again, ME, Dr. Yung-Chang Lee, Beline, our great colleague from the Hub, and Grace. So let's get started with the introductions. I'm Ali Reza Mohammadi. I'm a faculty member in the ECE department. I started back in 2018, and my basically way to get introduced to the concept of sustainability in an official manner was through the ASEE mini grant program, and then Samir and I built off on top of that. Then let's do the round introductions. And
all right, Delian Toller Smith, it's good to see you all. I've been here since 2017, and I've been teaching Engineering 100 since then, except for last year I was on modified duties, and also senior design. So the course that we'll be introducing this framework this year is in Engineering 100.
My name is Yung-Chang Lee. I'm a mechanical engineering. I've been teaching internal combustion engines, thermal science, thermodynamics, and some others. But these, in my classes, typically we talk about the efficiency of complex machinery and stuff. So I think this, what I teach in this initiative kind of aligns very well.
so your courses, in a sense, create a lot of carbon footprint. It can serve both good and bad, but hopefully for good.
Hi, my name is Azim Hafid. I did my PhD from UM-Dearborn. So I came to the US in 2015, completed my PhD, and then I joined ECE faculty in 2020. So I have been teaching here since 2016. I have taught ECE 210, which is circuit analysis. Then I have taught digital systems, signal and systems, microcontrollers and embedded systems. I have taught control systems, signal processing, communication systems. So almost all the
whole
courses of
ECE.
ECE, except a couple of courses.
You could teach the whole the degree program.
Yeah, thank you. Mainly, I'm interested in implementing project-based learning in my courses. So over the last 2 years, I have implemented PBL in embedded systems, circuit analysis, and one good output which we have seen in last 2 years is that students, they are coming from other universities to take those courses. So for example, last year there were 4 students who came from Western Michigan University. In last semester, we had 4 students from UFM and Arbor. In this semester, we have guest students from other universities as well.
Which class?
It was in embedded systems. So 4 students came.
Amazing.
And then one of the main reasons they quoted is that in our university, the lab component is very good in embedded system. And even some of the companies, when they are advertising their jobs now, they are including embedded systems right away. That they want good grades in embedded system. So I'm looking forward to integrate PPL and EML, and I want to learn from EOP.
And
that
this is
how-
great because even the Western Michigan University students or other campuses that come and take our courses, at least on a transfer guest level basis, they also get exposed to it. And it would be great if we can, in your class, you record. Okay, so I've got these students from these universities, because then to the Lemelson Foundation, we can say, hey, we have been also able to educate these students from other campuses, because as Samir said, they're looking into impact and scaling up, spreading the word about sustainability and their duties. And of course,
So I'm Samir Awashta, a faculty member in the PC department, colleague from Hazim and Rizal. Basically, that EOP mini grant is how we got introduced to this, right? So we saw this announcement and we thought maybe robotics sustainability is unique, right? But then it was really a challenge to think about, okay, because robotics isn't climate change, isn't, classically a sustainability problem. But then we started brainstorming aspects of robotics that have sustainability aspects. So you can use robots for solutions, sustainability of robots. Wherever you look, sustainability plays a role. That was a learning exercise for us, and the hope is that we would have the students have a similar experience where they think about sustainability, no matter what they do. This is Alariza's show. I'm here to support. I might get up and take pictures and stuff. So when we report back to Lemelson. So thank you for being here. I'm glad to help.
and of course, two special guests, the coordinator of the sustainability program and Belen from the hub. So would you please introduce yourself, the things that you do? You can start with Belen, and then of course, Grace is our sustainability expert. So again, Samir and I do not claim that we are the experts. So any part that we basically we are, moving basically off,
Yeah.
please don't hesitate to stop us and correct us.
Yeah,
So
I see sustainability as a, kind of like a jack of all trades, but a master of none. And that's because it intersects with so many different things like you're describing. So I can jump in if you.
yeah, absolutely. That's how I do. Yeah, that's how I do.
My name is Grace Mays. We have a Planet Blue Ambassador program here, and the goal of the Planet Blue Ambassador program is to create a culture of sustainability on campus. So it perfectly integrates with what the goals of the ELP program are trying to accomplish. So just stepping back, I've been here on UM-Dearborn's campus starting at the end of 2022. The Planet Blue Ambassador program at the University of Michigan has been going since 2011. So it was established in 2011 on the Ann Arbor campus. And then in 2022, it launched on all three campuses. And part of the reason it did that is the university has made carbon neutrality commitments. The simple version of that is that we're aiming to be carbon neutral by 2040. And there's 4 parts to that commitment. And one of the parts to that commitment is to create a culture of sustainability on campus among faculty, staff, and students. So I would argue that this EOP program is doing exactly that by integrating some of the people from the hub for teaching, faculty, and then integrating that into student classrooms. And so the Planet Blue Ambassador program is actually out of funded through the Graham Sustainability Institute. And they are a fantastic resource. You can check out their website, but one of the things that I do want to highlight is that they have a Catalyst grant program. It's really focused on funding interdisciplinary research projects, and it's usually seen as like a seed starter for different research projects, so it's like $10,000 grants. But they're also really looking to fund projects that act on research that has been done in the past too, to put that research into action. So, yeah, that's a little bit about the program. We just briefly, we have a part of the program is the training that comes with it. So, you talk about culture change, so we're aiming to get everyone on campus certified as Planet Blue ambassadors. And so how people do that, there's an online training that you can take, or we give the training in like a live presentation format. And I do this in several different classes, and there are lots of classes that also offer the online version of it as like a reading assignment. So, and that training covers, I would say it really hits on the environmental literacy part of this EOP. It's really sustainability 101, but it shows you how integrated the social aspects are with sustainability. So it gives that like base foundation for launching off and thinking about those things in the practice-based learning that you do, and the different projects that students can do in class. So the different topics that are covered are like sustainable food, which I can go into depth about how that connects to engineering, but we can talk more. Other things is waste reduction, community engagement, protecting the Rouge River, which connects them with water quality and quantity and things like that. What else did we cover? A few different other topics, but oh, I mean, the energy side of things is really huge. And that's a lot of the work that's actually happening on campus. I, again, jack of all trades and master of none, so I kind of serve as a connector when it comes to those sorts of things. I don't work directly on the energy projects, but we have an energy manager for the campus. And my position sits within facilities operations, so there could be some practice-based learning opportunities that could use campus as a living lab, essentially. So I'll stop there. But it's nice to meet you all.
Thank you very much for coming. Really appreciate it. And Grace actually was the person who contacted us. And I really appreciate it. I mean, it was her initiative. She had read about the story, and then she just sent an email to us and basically started from there. Of course, we've got our great colleague, Beline from the Hub, both Beline, and I'm honored to work with Carla and Beline since back in 2018. And they've done many great things for campus in terms of enriching the education experience. So, Beline, please.
Yeah, I've been here. Thank you. I'm Belen Garcia. I've been here since 2017. And I work in the Hub for Teaching and Learning. Usually we're the ones sending the newsletter to faculty on Friday mornings, and about different topics for to help mostly with teaching, but sometimes we include a few other things. So if you want to check, we have a blog, we have a newsletter, and for me, I'm very interested in sustainability. My PhD is in technology for education, but my dissertation was about how middle school students can learn about sustainability by playing a computer game. So, and I was there with 8th graders. So yeah, my dissertation had like a chapter about sustainability, environmental literacy, and all those things. Yeah.
Even the gaming would do some reinforcement learning on the side of the students. They train them.
Yeah, and that was very interesting because it was interactive and they could see how taking decisions will affect their city. They had to build a city. So, for example, the girls, they thought it was very cute to have a bakery, but having a bakery has an impact and all those things that they never thought before. So yeah, I heard many comments like that.
Very interesting.
And they have also to create jobs. It was not only the side of the environmental side, the city had to have some jobs for people living there.
So back in the days when maybe Samira and I were teenagers, we had to, we played Red Alert, and it was about
It's
killing, and
organization.
now the strategy games are moving towards
Yeah,
also.
there's always been civilization was one of my
Yes.
favorites too. It's one of those, you have to manage resources, and it's really tricky.
But
Just this week I was in comment, my kids discovered the Minecraft world
Mm,
about the human body, right? So you go to you actually travel through the digestive system, see stuff, and it's interesting how we can learn,
from gaming.
Yeah,
There are some games, there are
there's plenty
some.
of games that are terrible, but yeah, there's some good ones.
Yeah, those are games for education, so it's completely different to video games, so, yeah. And there are some organizations actually doing those games. Because they notice, when teenagers are playing, they don't, wanna end. So very opposite to what they do in classes,
Mhm,
so
mhm,
they cannot run fast enough after class. So, yeah.
Wonderful, wonderful. And basically here's the workshop structure, and then we'll go for the first break. We will, in the very beginning, we'll do a very brief dive into what's this EOP framework, what are its learning outcomes, and we will see what are the relationships between the ABET outcomes and this famous UN SDG goals, Sustainable Development Goals. And then we'll do, the next section we will do, it's a quick start guide for the courses. And we'll do some activities together. There's an example, and then we'll see how we can basically come up with ideas to, based on the ABET outcomes from the courses, we can basically find the mappings in the EOP and then basically integrate it within the course through a project or homework. And you'll see, we don't create it from scratch. You'll see things would be very interesting. And then, of course, unfortunately, or fortunately, we'll have the ramp up and the ending of the session. So this is the end of part 1. Let's go for a 10 minutes, 15 minutes break. We're good with time, so we can take our time, and then we'll come back and continue. So how can I stop recording?
Pause, probably just,
This one?
yeah, up above it. Pause recording. Right above this stuff.
Oh, yes. Yes.
Oh, screen sharing is paused. I meant to pause the recording.
Okay. Thank you so much.
So weird angle.
Fabulous. So let's get started with the second part, which is about just seeing those 9 outcomes and how there's the mapping, and we'll do some activity together in this last, in the last part of the second session. We'll then go for another break, and then we'll come back for yet another more activity intense session, and then we'll be done for the day. Okay, so brief dive into the framework. So the thing is that there are 92 learning outcomes associated with this EOP framework. Do not get afraid. It's very manageable, as you will see, because they have been able to put all these 92 into 9 main topic areas. And then those 9 topic areas map nicely with the basically the ABET basically outcomes. So at the very core root of these 9 topic areas, there's the systems thinking, because it's very important for the students to have this systems thinking mindset. So, but let me also, this slide is better, because they're fundamental to understanding complex interactions in engineering tasks within ecological and societal contexts. Because, I mean, systems are interconnected, just as Grace mentioned, Samir said, it's something that the students should understand how the systems would interact with each other. And they would create a, basically an environmental and social impact. The second topic area is, of course, we have the next level, which relates to knowledge and understanding for the students. It includes environmental literacy, responsible business and economy, and social responsibility. Now, just for a quick also thing, all these material have been shared with you in this folder. Even the assessment tools are here, and I'll be going through them. But basically, feel free to download and use through the workshop, or even if you don't have a laptop, that's completely fine, because we'll do everything also on the screen.
So I'm about to email the direct link, so it's easier, top of your inbox, so that we can get it quickly.
Now, of course, there's also the more technical skills level, which would be environmental impact assessment, material selection, and design. This is more technical on the engineering side, and of course, the highest level are the leadership skills, which include critical thinking and communication and teamwork. And as you will see, we have also created a pre-survey and post-survey for the students that would see how they would integrate these sustainability practices after they graduate from UM-Dearborn and start working in the industry. It closely relates with these leadership skills. And then all these 92 basically outcomes fall under one of these 9 key topics. And we will see how there's also a very interesting tool that ASU has developed, and also a piece of Python code that you will see. It's interesting. Okay, so this is, as we saw, this is another representation. Systems thinking, again, is at the very core of the EOP 9 key topics. And we have got basically the knowledge and understanding part, which includes the environmental literacy, responsible business and economy, and social responsibility. They should understand that their actions would have impact. We've got the technical skills part, which is environmental impact assessment, material selection and design, and then the leadership skills, which is critical thinking and communication and teamwork. Perhaps along the lines of, I mean, if they become someone like Bill Gates, they can lead the initiatives at a societal scale for, I mean, creating sustainability impacts. Now, of course, one by one, we can go and see what each of these key topics is about. Again, systems thinking is fundamental to understanding complex interactions in engineering tasks between ecological and societal contexts. And it's at the root of all the key topics. One thing that I should also say, so it might be the case that you might be doing an activity with your students, and we will see it in a few bits. And it might have all these things at the same time, but to different scales. And there's a very beautiful tool that you can use to create a spider-shaped graph to see how basically things would map out in your course. You'll see that at the end of this second part. And we've got the responsible business and economy, and environmental literacy, and environmental impact assessment. These 3 goes to more the understanding part. They also closely, if you pay attention, there is a relationship with also the Bloom's taxonomy, because there is the understand, design with a specific impacts. So these are more at these 3 are more at the we can say the bottom of the hierarchy of Bloom's taxonomy. So understanding environmental impacts, sustainability practices, and ecological balance, and responsible business and economy. How sustainable practices can be incorporated into business models, which was not part of the basically decision-making in many industries back in the days, but it's been changing throughout the years. Even you can say the initiative that our university does through the Graham Institute relates to this, basically responsible business and economy, because the university is in a sense a business and they want to play responsibly. So the education business, but doing things in a responsible manner, because you want to decrease your basically carbon footprint. That's another interpretation. So even when we are talking about this to the students, we say, hey, the university is also involved in this activity. They're doing this. And environmental impact assessment, which is, of course, the importance of assessing environmental impacts in all engineering projects. So material selections, design consideration are more technical skills. How do you choose the materials to minimize the environmental impact? So the thing that we did, for instance, in our EC 4641 mobile robotics course at UM-Dearborn, it was the ASEE mini grant, was asking the students if they could change the wheel design for the mobile robots, the on-run robots that we have got. They have got a certain set of materials. Can they come up with a similar thing so that it would give them the same traction for the mobile robot, but environmentally it's more friendly? We'll see that the examples of how to integrate these concepts into the course, but I'm just giving a very brief example so that we know they're not just abstractions. Design considerations, of course, you need to incorporate sustainability into the design process to create more efficient, durable, and environmentally friendly products. Critical thinking and communication and teamwork are the highest level. They go to the leadership. Critical thinking, how to approach engineering problems with a mindset that values creative and sustainable solutions. And communication and teamwork, of course, it's the importance of effective communication and teamwork in achieving sustainable engineering goals. And of course, we've got the social responsibilities, which engineers must advocate and practice inclusivity, equity, and justice in all aspects of their work. So the key 9 topics, and then we have got the 92 outcomes. Now, the question is how these 92 outcomes would fit inside this basically 9 key topics. And the answer is there is a very nice Excel sheet that ASU, Arizona State University, has created, and the Lemelson Foundation has shared with everyone. Now,
Can you boost the font, like control wheels? Zoom somewhere. I guess it's on the bottom right.
yes. So I'm just,
Oh, okay.
so this one, if you see, basically it's the core root, and then one can go one by basically create a spider graph from how their course activity would include these elements. So you see that there is the systems thinking at the very top, environmental literacy, responsible business and economy, social responsibility, environmental impact assessment, design, critical thinking, communications and teamwork, and so on and so forth. Now, let's say that you're interested to know what are the outcomes in the systems thinking area that is relevant to the activity that you do in your course. And I'm sure that we already do some of these in our courses. And then if you see in the systems thinking area, there are the core learning skills, five of them, and more advanced ones. which include 4 of them. And then let's say that we do all of these together. And then we would put 1, 1, 1, 1, and then of course 1, 1, 1, and 1. And let's say that it's only systems thinking that we do with all these outcomes. Then the thing that we would get is this, of course, because in the other areas, we are not touching anything and we are not including any of the other ones. But as we start adding the things, because it might be the case that, for instance, in the systems thinking, we do only, let's say, nothing of this. And let's say none of these advanced zero and 0. And then we go again back to this one, EOP design tool, of course, because we are only doing 5 of them, so it goes up to this point. Now, of course, we can also go and see what are these outcomes. We can expand on this further, maybe if. So this one is, so we can double click. So it's about explaining interconnectedness, core outcome 1, and how all human-made designs and activities rely upon and are embedded within ecological and social systems. Now, there are also the other ones. Now, there can, basically we can find the 92 outcomes. Let's also go through the documents that I have shared. It's in this EOP framework, basically master document. And they go over all the 9 key topics, including the basically outcomes. So you see that at the core, there are these 5 elements. At the advanced level, there are these 4 elements. Now, interestingly enough, you see these, there's also a mapping with the Bloom's taxonomy hierarchy. So this one, which is the explain, it's at the very bottom, because according to Bloom, that's the needed thing. Now, this interestingly, there's a mapping that you see these orange circles, it's outcome 4 of ABET. Or let's say we'll go to this. This one, it's in the middle of the Bloom's hierarchy. Apply relevant concepts from required disciplines to the study of real-world problems and their solutions with ethical consideration for community societies. This maps to outcomes 247 of the ABET, and also this circle, it means that it's also related to the UN SDG learning goals. So there is this beautiful mapping that they have created through the.
I would comment that it relates to the ABET outcome, but not necessarily totally covers it, right? Like you could do an ABET outcome and not talk about sustainability.
True, absolutely.
But it's an opportunity to, in that outcome, to also talk about sustainability, right? So
Exactly,
they're
true.
kind of giving you a hint as to where to look, essentially.
Exactly. So
If your course covered outcome 4, then maybe you could cover these 3 under that outcome.
exactly. And the interesting thing is that this document here, 13 ideas, actually does, and we'll go through it, but through 13 examples, they talk about what they can do regarding the courses. So for instance, in a systems control course, you can talk about energy efficiency and you'll see the mapping. So we'll come back to this document as well. But there are examples, worked out examples, because you're already giving some basically homework assignments, projects, labs to your students. You only need to add some few elements to that to make it relevant to the EOP. You don't have to create things from scratch.
You
So
can
if-
have, yeah, you can have like a lab experiment and you add a question in the report, right? Like in the report, talk about sustainability or consider the different materials or. So you kind of salt and pepper the sustainability stuff to existing assignments, right?
We'll see all these in more detail, but just to give you an idea that even the students, so let's say that you include a question related to sustainability in that project. And the students do not know what to do. Okay, so I don't have any clues about waste management. And I don't have any knowledge. In addition, they can go, of course, search, do a search online, but there are very interesting tools that the partner of Lemelson Foundation have developed for the students so that they can go and learn and answer those types of questions. One of them is this Inventing Green Toolkit from the Venture Bill that exactly talks about all these different ideas. So inventing green ideas, sustainability assessment for innovators. They have also got, so we'll come back to this. I'm just giving you a very brief overview. They have also got in the EOP links here, I have shared the places that the students can go and view yourself. So Ventureville tools, they have developed many interesting tools for basically assessing, answering questions regarding design and sustainability. So you see here, if they want to learn about greener materials, lightweighting, circular economy, the student can click here and then go and see what are the things. There are also videos if they don't want to basically read the whole thing. So let's see one of these videos together because they have been developed by Autodesk and it's fun for.
You're getting the most use out of the materials and energy that go into your product. A great way to do this is by extending its useful life. A mobile phone may not weigh much more than 100 grams, but manufacturing it can cause over 80 kilograms of waste.
So of course, the students do not like to go and read. With many of these things, they can go and watch a video. And let's say that you have designed something about greener material or sustainable design, they can go and basically watch the video and then think. Because one element about project, when we say project-based learning, based on my interpretation and also the things that I learned from Worcester Polytechnic, it's about being open-ended, not having a clear 100% yes or no answer, but rather that challenge that comes to them that makes it project-based. Because if it's open-ended, then they have to think creatively. They have to work in groups to come up with answers. Even the instructor himself or herself might not have the answer, the correct answer, which is fine. You look to the process, how much effort the student has put into the basically project, how has been their basically lineage of thought, how they have basically thought about the problems. So let's continue watching this.
Design a phone that breaks after a year of use. Your customers will need to buy a new one every year, and another 80 kilograms of waste is created. Over 10 years, that's 800 kilograms per customer. But if you can extend the phone's life to 2 years, then half of your manufacturing impact effectively goes away. If the phone lasts 10 years, that's equivalent to 90% less material use and waste. A virtual engineering miracle. Products go through a basic life cycle, from raw materials to manufacture to use and eventual disposal. To maximize your product lifetime, that is, to extend its use phase, you can either make it more durable, so that it's harder to break, or you can make it easier to give the product new life through repair or upgrades. You can also provide an elegant end of life for your product by designing it to be easily recyclable. This skips the disposal phase and helps to ensure that the materials can have a much longer life than the product itself. Sometimes you can give whole components a longer life than a product through remanufacturing. This is when companies reclaim used parts and build them into new products. Most of the time, you'll want to use a combination of these strategies. The ideal is to have a product lifecycle that's entirely closed loop, never needing any virgin materials or causing any landfill. Companies are starting to care much more about recyclability and reuse because of increasingly strict product stewardship laws. It used to be considered good business to make things that would break quickly and get tossed away. New rules are making designers rethink that strategy. Before we discuss how to design for a long lifetime, let's remember that not everything should be built to last forever. A takeout food container that will be used for 5 minutes shouldn't last 1,000 years and will cause problems if it does. Things like this should be designed to have a good end of life, to recycle easily or to biodegrade quickly and harmlessly. At the other end of the spectrum, chairs, boots, or other goods that serve long-term recurring needs still need to be designed for good end of life, but should also be physically and stylistically durable so they can last a lifetime, maybe even longer. These are obvious examples, but most products, from phones and laptops to refrigerators and cars, lie somewhere in between. These sorts of products, especially technology-heavy ones, tend to become obsolete or break prematurely. So repair and upgrade are key considerations here. If done right, sales of parts and service can generate a whole new stream of revenue for your company, maybe even at higher margins than just selling more of the product. For these strategies to work, the ability to disassemble and access the product components is important, and the best designs will incorporate all of them. For instance, when you repair and upgrade, some components will reach their end of life while the rest of the product keeps on living. It's important that these components end their lives well through recycling or biodegrading. And durability can be extremely important in medium lifetime products that get a lot of abuse, like mobile devices. You'll find the right strategies for your products by keeping the whole system in mind. Ultimately, your product will be touched by many people. You can enlist all of them to extend its life. Strategies to make a product easy to disassemble can also make it cheaper to produce. This puts manufacturing on your team. Good design will empower your users to repair, upgrade, and maintain your products. Choosing good materials and creating take-back programs can bring recyclers on board. Design for lifetime is the best way to bring together low impact and high quality. And as a designer or engineer, your choices can make a big difference. Now let's check out some specific ways to do it.
Okay, so interestingly enough,
This is great for like interior design and human handle that's watch.
yeah, absolutely. So once you do that identification, you create your base. We will see that in the third part. You create the component. I mean, the smart, just as Samir said, the sparkling of the salt, pepper, of the sustainability into your homework or project. Then you ask the students, okay, you can make up by yourself, or go watch these fun videos, learn something, answer the questions, and don't worry, it might be wrong, but that's totally fine. So,
Simplest, the one thing I did like early on was, simplest thing was just added a reading assignment. So read this article about sustainability and robotics and answer these questions, right? It was like one of the easiest things you could do, but that's a new assignment. If you make modify existing assignments.
now, it might be the case that you're not, basically, you don't want to go through all these, because at the end of the day, it's the 9 key topics that you basically are the most important. And then you want to still create a spider map like this. But of course, you can basically on a subjective basis, you can say, okay, this activity that I have designed has got, let's say, 0.1 systems thinking, 0.2 environmental literacy, 1 critical thinking, the rest 0. How to do that without using this Excel worksheet? So the thing that here we have done is basically, there's this Python code that I wrote, and we can run it on Google Colab. So you don't even need to install Python on your computer. You can actually run the codes. The only thing that you need to do is to upload the Jupyter notebook that I have shared on the shared material with you, and then work on an Excel worksheet, fill out the rows, and upload up to the Jupyter notebook, and then you can create the mapping. So let's do it in a step-by-step manner. So we first go to the Excel worksheet that we have basically created. So the EOP metric results. Yes. And then let's see which of the elements or activities can be weighted like this. So maybe we can start with Azim. So Azim, what thing you can think of? Let's say a sustainable design for a circuit. You want to include it in your project or something similar to that. Okay. What thing comes to your mind?
Which course are you thinking to join some?
Electric.
Yes,
system.
210.
210.
Do you have ideas already how, for which assignments?
So, I'm thinking of a project, so right now, we have a problem of air quality. So if the air quality is bad, so it has direct impact of human emotion. So we can give a project to students in which we can make it energy efficient. Yeah, for example, we can design the lighting system on roads, which will turn on automatically at night and turn off during the day. It will indirectly reduce pollution as well. It will reduce energy as well, and it has many other benefits.
Fantastic. Now, having this description, let's go one by one. And on a subjective, you don't have to be 100% mathematically correct. Let's go and see how much, let's say from the perspective of systems thinking, between 0 and 1, how much of that would be considered to be a systems thinking, the activity that you've designed? How much of systems thinking does it involve? Between 0 and 1. And don't worry if
I'm guessing not too much in this case, right? 'Cause
Let's
not
say-
considering many things, it's
Yeah.
a solution that has.
so, it's 0.1.
Point one.
Probably, yeah,
0.1. Then
they work as teams.
communication and teamwork. Are you going to make them work together in teams or deliver on individual?
Work in teams.
And do they also do presentation?
Yes.
So it'll be high. Yeah.
So it would be high. How much do you think they can assign work?
They will make a poster as well in the form of groups, so probably 1.
1. Critical thinking, how much they need to?
0.5.
Design will be really quite high, right? Because that's what it is, it's a design.
Yeah, design will be high.
So.
0.9.
Okay. How about material selection? Do they do any material selection or
Yes. 0.5.
0.5?
I guess like the type of lab, LED versus not LED, so.
And then will they use BJT or will they
Oh,
use
that's-
lights and?
Okay,
Then environmental impact assessment. How much do you think?
Probably 1, because yes, they will have to come up with calculations that how much energy will be saved, and in terms of that, how much gas will be saved, coal will be saved, etc.
Good. Social responsibility. It's fine. If it's 0, that's fine. That's completely fine. If it's 0.1, whatever. Because you don't have to cover everything. It will give you in a sense, a semi-quantitative picture of the things that you are including related to EOP framework in your educational activity. It's fine if it's 0, that's fine.
There might be a social impact that because of better air quality, the mood of or emotion of human beings will be better. So maybe 0.1.
Point.
I would say there's ways to make sure that connection is formed by talking about the impacts of communities around either the power plants that you're speaking of, whether it be coal or natural gas based. Because they're typically located in neighborhoods that have previously been redlined, what means that they were neighborhoods marked as, not as valuable, so people that were socioeconomically disadvantaged had to be located near there. So, yeah, I think there's like added intro information that you could integrate when talking about the introduction to this project.
Some reading
Yeah.
some.
Exactly. And there's a huge impact, especially locally, connected to exactly what you're talking about. So yeah.
So responsible business and economy, maybe zero, or because it's not a senior design thing, that do they do some financial analysis, or if again, the thing is that it's completely fine if there, you give zero to some of these, it's fine.
There is financial analysis as well, because,
Okay, so that's good. How much?
yes, because, if, let's say that if the lights are turned on during day, so it will have, the energy will go up as well, so maybe 0.5.
0.5. 0.5. And environmental literacy,
0.5 as well.
0.5. Great, fantastic. Okay, so we have completed this Excel sheet for Azim's course. Then we go back to, or basically Python, or even because I want to show you how to create things from scratch. Let's assume that even it hadn't been preloaded. So, you know, because of our subscription, and we've got the Google basically account, so we can access Google Colab through that account as well. If you're signed in into your email, which I have, if you basically do Google Colab, you go here.
So we have a UMish account for that?
Yes.
And it's on my students.
Yes. And then here you see, it's Yumish.
You just have to log in with your.
Yes,
That's it.
absolutely. And then you go to file, and then you want to upload a new notebook. Or upload new notebook. And then I browse. Okay, so I don't have anything here. So I go back to the Google folder, which I have shared with you. I go to the assessment tools, and I then download this Colab Jupyter notebook. IPYN. Okay, so it's downloaded. Then I go back to my, again, Google Colab. I browse, and then I have buttons. And it's uploaded. Now, we also have to upload our Excel worksheet, the one that we created based off the discussion with Azim. So I go here, and then I do upload. And then I go to EOP metric results. This is the one that we were working on. And it gets uploaded. Then we run the code. So it's loaded successfully. And then we create the spider chart. The second part does that. And here's the was uploading so let me go back. If you remove this. Where's the recent files? The recent files. Metric results is 1055A, and it should be the correct. Upload, and then hopefully. Okay, so this is the spider chart according to what we discussed with Azim. So you see the how it shows in a picture, and how Azim's basically project. Now it's interesting, it has taken the shape of a bird, or the environmental, so very nice. Then the thing is that we can also add more of this to our Excel worksheet. If you're doing more than one course, you can even add more mappings to this. So let's go with Bunton, and again go to our Excel worksheet. Where is Excel? Open here. And let's see. So, Dr. Lee, what are you thinking about?
Systems. Well, I'm thinking of, project and. Someone who is that.
In the thermodynamics course?
As a new
Yes,
project on sustainability, specifically on an existing project, if you would.
It is, yeah, we already have the project.
But you can,
Course.
just as we said, you
Maybe
can
I'll
put
create
pepper and
a
salt.
brand new one and, some dynamics maybe. So, next. Yeah, probably that's better.
I guess for the exercise, pick one, let's go through it together.
Yeah, okay, systems thinking.
And again, it's completely fine if it's zero. That's fine because okay, so it doesn't have
Of course,
system
so everything.
thinking,
It's like ABET,
or
right?
it's
Not every
small.
course covers
We
all
don't
the
have to cover everything.
Yeah, maybe, 0.2.
0.2. Communication teamwork.
It's going to be a group project, so 0.5.
0.5.
Design 1. Design.
Designs.
Material selection. 0.4.
Mhm.
Zero.
0.1.
0.1.
Responsible business and economy. It's fine if it's zero.
Yeah, it could be zero.
Zero.
It's, yeah.
And environmental levels.
0.67.
0.7. So we can also add this and upload, and you will see that another spider thing would get added. Now, a very interesting thing that Dalian and I were thinking of about the engineering 100 is the autonomous vehicle basically making decision on whom to hit, whom not to hit. So the idea is that because it fits very nicely with the element of social responsibility as well. If you're coding, let's say, an autonomous vehicle, it runs into a situation that there is no escape from it. Then it has to make a binary decision, whether to hit one or whether to hit 5 people. And also, let's say that the perception system, and Samir is the expert of perception, is smart enough that it can say, okay, so this one guy is 90 years old, 85 years old. This basically 5 people, it includes a 30-year-old, let's say two mother, father, parents, and then 3 kids. Then it has to make a decision based off that.
The trolley problem gets tricky, right? And then at the risk of the driver or not at the risk of the driver.
Assuming that it's basically it's completely autonomous, driverless. And also there is no passenger. Let's say it's just an Amazon autonomous truck delivering something to someone. So one thing that's in the very basically this idea was also partially came from the days before the EOP. Dalian had asked me to go and give a talk about robotics, and I thought, what can I tell the students in the first year about the ethical things in robotics? And I saw these, actually I showed them in the beginning of the activity, this very famous Isaac Asimov 3 rules of robotics. So
Well, back in 1959, I began writing building stories. But by the time I hit the children's degree, there was a pattern and I really don't buy. That's an observation. They said I was having my.
So you can't hear very well.
Yes, back in 1959, I began my EOP stories. And by the time I went into there was a pattern of these stories which John Campbell, young astounding science fiction by Video Bobby, talked about to me. He said I was having my robots behaved as though we were guided by 3 laws. The first law was that a robot couldn't hurt a human being or through an action allowed to come to harm. The second law was that a robot had to obey orders given by human beings, provided that it was admit to the first one. And the third law was that a robot had to protect its own existence, except for that, the first 2 laws. And after that, I always used to have the stories evolved out of those 3 laws, out of the mutual contradictions, out of the differences and the congruities and so on. Now, the thing is that scientists say that we're not to help, that they don't according to these laws, and also that almost all scientific writers have adopted them as well. Sure. That's true about the science fiction writers and doctors, but they're not taken for granted. No writer actually quotes it except myself. But the readers are so used to it now that they know that they take it for granted. And somebody writing in an architectural journal pointed out that these laws hold for tools generally. Number 1, a tool must be safe to use. And 2, provided it's safe to use, it's not to do what you want to do. And 3rd, provided it's safe to use, it does what you want to, it's gonna last. But I've learned 3 laws of robotics, number 1, science. There are those elements that the machines can combine in practice science. Well, of course, the 3 laws of robotics were originally invented by me. I wrote a book for it by this side motive, because before I wrote my stories, most program stories were filled. I mean, this famous stuff about the moment destroying his creator. There are some things that men were not meant to know. However, having worked with the 3 laws for now 35 years, I was asked to write a Roman story to add to all Roman stories, so I wrote one. These Romans became so intelligent that by any reasonable definition, they find themselves as human beings, you see. So that now the 3 laws of Romans robotics become the 3 laws of mechanics. And we write that to the Frankenstein motif. I received letters from readers saying, "Does this mean you're never going to write any more Roman stories?" And I won't dissect, don't worry, if I think of a good Roman story, I'll write it anyway.
Great. So again, as I said, credit to Dalian, because it was through that invited lecture that I originally came up with this idea, and hopefully we'll implement it in your class. And then let's go and brainstorm together.
Well, the other thing I want to add is as we're sitting here, we've been thinking about how can I maybe connect it to the project? Yeah. So they're making, like line following robots this semester, for little cars. And so thinking about, is there any decision making at a really simple level we could introduce that thinks about either sustainability or ethic, like how can we kind of merge these ideas together when they're designing, because the line following car is really simple. So, and it can become boring, but what would it be more interesting if we were to put a decision in there that they have to consider, so just, I'm thinking, if anyone has any thoughts on that.
Because the purpose of this experiment, the line following is really technical, right? Like
Mhm.
Arduino learned to work
Right,
for the first time.
Yeah.
It's
And
hard to think of a societal issue,
You can put maybe some the toys of, the small toys that represents pedestrians.
The closest thing I can come up with is they use line following robots as line following robots in industrial settings, like 20 years ago, the Toyota plant ones. Before they were like mobile autonomous, they would have like strips on the ground.
Mm.
These robots would follow the line and haul like racks and stuff like.
Right.
So maybe there's a manufacturing angle there.
It could be. And it doesn't have to be line following. I have 3 days, so I can change the project you're going to, but, just thinking how could we maybe spice it up a little bit.
Into a project, yeah.
Yeah.
So line following robot Can I get a little background on that? 'Cause I think I have some ideas, but I don't know if it's relevant.
It's literally imagine a car, a toy car that knows how to identify if it's on a colored line or not.
Okay,
So black tape, can it stay on that line and follow the path wherever it needs?
okay,
And so in that case, when we think about in manufacturing facilities, that's really important because you're dealing with humans and machines.
okay.
And maybe even autonomous machines moving between them, so that can be really important.
What is a typical application? So that robot's following a line, but what is its purpose?
That's what it,
Well, the purpose for the class
Yeah.
is for them to program for the first time,
Right.
to integrate. for
So
the
it's
first time.
something like this.
Well, that's like
Oh.
more of the racing kind, but yeah.
Yes.
yeah, but yeah, for the students at the end, they just know how to program, they've done some prototyping.
The
They-
freshmen, right?
Yeah, they're first year students, so they're just thinking, oh, I'm just getting used to these components, I can build something, I can do a little coding. And then I can test it and retest it if needed, so that's kind of at the lowest level.
And what's the programming language?
We're using Arduino, so it's like C++.
Do they actually build the robots?
They're doing some building, yeah, they are building, so we give them components,
Yeah,
and we give them basic introduction to all of the skills that they
So
need.
maybe component selection or something.
yeah, so like the supply chain of the components that you use to put it together. Yeah, the sourcing of the materials used, the usability of those materials, so like, could this be used? Could you design it in a way that students in future classes could reuse? Those components, and that's applicable for, I think, in the real world too. It might be designing for future classes, but if it's put into a real world setting, those are questions that would be asked as well.
So maybe going back to that first video we saw,
Mhm.
and maybe I'm moving ahead of our timeline, but I just thought to add
That's
that.
great. And
But yeah, like if we look at the first video, how can we think about durability of the material that's using, where they're coming from?
This is
so
great.
You can ask them to help you tweak the assignment for future semesters.
Mhm.
There could be a question posed, right? Like, okay, I'm gonna do this every semester. Is it sustainable? Am I wasting, resources? What could I reuse? Get into rechargeable batteries, talk about. But sensors are quite reusable, right?
Yeah, Another,
Interesting.
another integration can be finding the smallest path from one point to another point. In this way, they will use some design, it will have some economical benefits as well.
So then let's go one by one and see this, how many, and give the grade, the scores, and then we'll upload to see that it can also show three spider charts at the same.
Definitely, if we're doing this, definitely one on material selection, right? It seems to be like the
And teamwork, one on teamwork.
teamwork and material selection, the rest is
One,
marginal. Right?
Yeah, I would think.
critical thinking, if we include that ethical dilemma, I think also one, design,
There's not so much design.
0.1 or 0.2. 0.2. One.
Yeah.
Environmental impact assessment. 0.1. Social responsibility, if they include that ethical dilemma, because they involve some elements, so this is 0.5.
Yeah.
Responsible business, oh, okay, so this is a very interesting thing. Because one of the reasons that, I mean, it's still, it's a new area in the practice of law, is who's responsible if the car, the autonomous vehicle, the robot kills someone? Is it the company? Is it the robot? Is it the programmer? Is it the user himself or herself? So maybe 0.5, 0.4. We don't have to be exact. And environmental literacy, maybe point.
That could be a reading about.
Point. Great. Now we have add. So there is no limit on how many rows you can add. You can basically assume that you are integrating these outcomes, the EOP into your 3 courses. And then you want to see how the shape of the spider charts would look like with respect to each other. The good thing about this code is that it also draws that. So you update this, then again, go back here, and then upload the new one. And time is 11:12, so we want to make sure that it's the correct one that you're uploading. 11, it's this one. And then we go back, reload the Excel sheet. Then we go here and draw the new charts, and you see the basically spider charts overlapping the this is Azim's bird. So which one do you think is Yunchen? Is it the red one or?
Yeah.
And the green one is the
And the hope is over a curriculum, all of them are covered, right, across courses. So not every course has to cover everything.
wonderful. Okay, so
I have a question on their behalf, I guess.
sure.
I guess what are we expecting from our first cohort?
We'll talk-
semester, Like a report?
We'll talk
I'll
about
give them a template
in the
probably.
third part. We'll talk
Oh,
about.
there's more.
Yes. Okay, so let's take a 10-minute break and then we'll come back and continue for hopefully not boring discussions. Pause.
Let's pause the share. Pausing the, I think you have to stop sharing to pause the
Stop.
video. Yeah.
Stop.
Just-
Let me know if there's anything.
Yeah, thank you so much for inviting and connecting. If anyone has any questions or wants to discuss ideas, for example, they have a project.
Yes,
and
yeah.
saying it's a brainstorming.
Yep, absolutely.
I would love to help out with that. And then I can send like a link to the online Canvas training. If everybody wants to be integrated that in any way. Looks like there's a lot of resources there too. And yeah, so we know.
Yeah, appreciate it, yeah.
Absolutely.
Yeah, especially your ideas in terms of like how we can,
Yeah,
how to look at the existing assignments in a different way. So
and I think there's a lot of ways to connect it to what's going on campus too.
Yeah.
So the kind of living lab opportunities that are out there.
Cool.
As a student, I would be really excited to connect to something that's going on my campus. you
Right.
know.
And this is the initial cohort of 4, so in the future there'll be bigger cohorts and stuff. So
Yeah.
Cool, great.
We'll create the
It was nice to
community.
meet you all.
Absolutely.
Thank you so much.
Thank you very much for coming.
In the lunch,
Absolutely.
appreciate it.
Thanks for coming, and we'll definitely be in touch with you.
Okay, that was great.
Great, so let's go to the third part. Now, a very nice, if you recall, we had this, basically the 9 topics and the 92 outcomes. They have summarized everything in Appendix A, which is page 26 of this Engineering for One Planet framework, and I have shared the PDF with you. It will give you a very, the big picture, big overview. And as I said in the basically beginning of the previous section of this workshop, there are the basic mappings between the ABET outcomes, and of course, you've got the ABET outcomes here, the 7 learning outcomes, and also how, for instance, the systems thinking encompass 2, 247, 24. So the red, the orange circle is ABET. And SDG, it means that it's related to the UN Sustainable Development Goals as well. This multicolored circle. Okay. This part we missed, and then we've got a quick start. So this one, this document that they have created has got 13 examples, worked out examples of how to basically define projects which are related to basically the EOP framework. And it might be an already existing project. You don't have to create anything from scratch. It might be an existing thing, but then you can basically start, as Samir said, sparkling pepper and salt of the EOP into that. And there's also, if you want to get more abstract, quick start guide, they've got this document. I have shared all these in our shared folder, including this slide. Now, let's, basically, this is the idea that I came up with. It's not the official EOP way of sparkling things, but this is the way of reverse engineering, how we can basically identify an element in our course and then integrate an EOP related thing to that. As an example, of course, the expert is here. Azim, circuit analysis. Let's say that you're assessing ABET's outcomes 2 and 4. It can be 2 and 4, it can be 5 and 6, whatever. So the very first step is to say, okay, we've picked the course. We say, what ABET outcomes do we want to assess in my designated course? What are that ABET outcomes? They're already there. And then through which homework lab project do you assess this out? So this is an already existing thing, because you always do the ABET, do homework lab assignment, and then you, through some of them, you do assess the ABET outcome. You just identify it in the very first step. So example is, let's say that 2 and 4, these are the ABET descriptions for 2 and 4. So still EOP is not there. Step 1 is just the identification of the ABET outcomes, of course, which projects, assignments, labs. This is something that I basically came up with. So it's not, again, EOP Lemelson official, but I think that is the fastest way of integration. Then okay, so let's say that the homework, one of the existing homeworks in the circuit analysis is about designing a simple lighting circuit using a power source, resistor, and LED. Assume that it's that assignment or lab or homework that you're doing the assessment of ABET 2 and 4, as an example. Then step 2, the thing is that, okay, so what is the suitable EOP topic area to the basically assessment tool that you identified in the previous step? Here, then you bring in the EOP. Let's say that you have thought, and it's the topic of environmental impact assessment for learning. The environmental impact assessment, which is EIA, and it's related to core learning outcome 4, which is question complex or contradictory information to make decisions among trade-offs. Who and what will be most impacted by the decision or marginalized communities part of the decision? Because in step 1, you have identified an already existing assessment tool, project, homework, quiz, whatever. Step 2, you say, okay, so the one that I have identified, to which of these EOP 9 key topic areas my thing is related to? Let's say, again, you go to EIA, which is the environmental impact assessment key topic. And then, of course, through that EIA, you can go and see so you go to the EOP framework document, and then you have said, okay, so it's the environmental impact assessment, and you see that it has got these core and advanced outcomes. And you go through them, scan them, say, okay, it seems that 4 is the most relevant one. And then, of course, you basically pick this 4. And then because 4 comes up with some questions, you can use that as the key map of creating the additional component that you would add to your assessment tool, already existing assessment tool. Okay, so the third step would be, of course, modifying the original homework project lab to include the elements of the identified core learning outcome. So the example is this. In that circuit design, consider all the non-technical factors involved in the engineering design process. The engineering design was the lighting circuit. Now, consider these prompts. What factors did you include in your decision process? These are the prompts that you would ask the students. Did you think about material sourcing in your circuit design? Environmental impacts such as carbon emissions or waste energy costs, community needs or impacts of the above on vulnerable populations. You can include this in your, so these additional prompts get added to your already existing project. And then basically, modified assessment tool by asking the students to include the following analysis in their assessment. How will you deal with trade-offs between both technical and non-technical factors? So you would add these. This would be a new, basically EOP-based thing. Now, the students, of course, they might not be familiar with the sustainability at all, but they can be guided to the Ventureville resources, the things that we discussed, and the videos. So, of course, we've got this wonderful page. So it's and then you see all these tools are the ones that the students can basically use to come up with answers. There is this Inventing Green toolkit that they can download. It's the PDF that talks about different design considerations. There is this tools for design and sustainability, which gets us to these this nice basically areas that Ventureville has basically designed. And then let's say that one of the things is related to greener materials. Okay, so you go to greener materials and you ask the student to watch this video. And this is the greener material, for instance.
Engineers and designers have more options than ever when choosing more sustainable materials. But what makes something green? Well, a good material is abundant and non-toxic, doesn't require a lot of energy and other resources to make and use. It has the right physical properties for its function. It also meets or exceeds regulations, has good end-of-life options, and doesn't drive up costs. That's a lot to consider, and it can get even more complicated than that. You also have to look at the life cycle impacts of the whole system. A compostable cup may be made of biodegradable materials, but if it's only used once, it's much less green than a plain old mug that's been used thousands of times. But don't worry, you can learn to manage these considerations and make smart trade-offs when choosing materials. That's what the next 2 lessons are all about.
Right, and the students can watch the video. Of course, there is no, I think, you can ask them that these are the resources you can use for learning more and answering these questions, or you can do your own search. So whatever they decide, we can be as flexible as possible. And so these are the resources that the students would basically use. And the thing is that, again, these 2 are very good additional resources. I have shared all these in our Google Drive folder, collection of many examples like this 13, and then this quick start activity one, if you want to do more. Now, the thing that basically is also very, Lennison is very interested to know is a pre-survey and the post-survey for the students who get engaged in this activity. It's about asking them how, I mean, did they know anything about sustainability? Have they heard something from about the EOP framework? Let me even go here because I have created the Google Forms that you can basically send to your students. You can create a copy and send to your students. So these are the assessment tools. Here's the pre-survey Google Form draft.
It's post.
Yep.
Post.
Oh, sorry. I mean, again, I have put it in the format of multi-question because our students do not have time to write detailed answers and just three pre-survey questions, 3 post-survey questions. Pre is, what's your current understanding of sustainability in the context of engineering? I'm not familiar, a basic, a good understanding, very knowledgeable. How important do you think sustainability is in engineering education?
We could add like, I don't know, in between here.
Yeah, yes. To what extent do you believe that engineers have a responsibility to promote? Post, after, I mean, doing that near the end of the term, you would ask them to also this. How has your understanding of sustainability changed after this course? How confident are you now in your ability to integrate sustainability practice into your engineering projects? And then this is very interesting because it also asks this question that it would change the culture of the society, the workplace. How likely are you to promote sustainability concepts in your workplace?
I think it would be worth it to repeat the two questions again. So then you have those one-to-one.
I was
And then
gonna
look at the
answer the same
short
question. I was gonna mention, wondering the same thing, if I could have one question. With
That's a good idea. Oh, yeah, sure. We can.
if that, if you
It's
can
easy
at
enough
least-
for them to click quickly through it. So
Yeah,
then you have a comparison, right? Like on average it was so and so, now after the course it's so and so, and then if there's additional questions.
Okay, that makes sense. Sure.
We have time, right? So that-
Yes. Yep, absolutely. So these are basically the assessment tools and the very brief introduction to the EOP framework. And then let's also do a very quick ramp up. Of course, in the previous part, we came up with some ideas, so I called it the first draft. And I was thinking a lot how to make sure that the workshop can deliver the best in the shortest amount of time with putting the least amount of workload on the shoulder of the faculty. So this was the solution that I came up with, the design of the workshop and then going through together. Now, just let's do a ramp up and then we can start if you've got any questions. Basically, the things that we saw in this workshop was introduction to the EOP. Why is it important? The 92 outcomes which go inside those 9 topic areas. And basically, we also saw some ideas of how to change already existing assignments or projects to include the EOP basically framework. Now, the only thing that we need to do for the course is to identify that element, that project or assignment, adding the EOP questions, and then basically doing the pre and post survey from the students. And also you can send me, or if you want to do the coding by yourself, you can send me just in the 9 key topic areas, the project that you have designed, how many of these factors basically are included, I mean, those 0 to 1 map, the 0 to 1 numbers, so that we would also create the spider charts. And what else? Another thing is that we've got the great resource of Hub and also the Grace, because she's got some ideas. One thing that I was thinking of is if your project turns out to be very successful, you might wanna talk to Grace to see how we can apply for grants funding. Grants. To further expand it. So, it's not a one-off thing. You can basically push the EOP card as much as you like. So hopefully this is a good, basically motivator and kickstart. Thoughts, ideas, questions?
Yeah, I guess near term, next week, as early as next week, when we do the pre-survey, then we should do assignments, to think about, incorporate some EOP questions.
And you can only identify one, let's say, homework, basically question, making it open-ended and making it a mini project.
Yeah. So, since it's the first cohort, we probably wanna cover at least, ask them to cover at least 3 outcomes or something, right? So, like-
So the thing is that once they, okay, so that's a beautiful point that you're saying. Okay, go through those steps, add the EOP element to your, basically homework. And go back to the 9 topics. Do the mappings between 0 and 1. You don't have, it's not really necessary.
They should all be,
Yes, yes.
it's kind of like ABETS, right? Eventually, over the curriculum, they would cover all the outcomes, but your course should cover 3 or something, right?
But don't force yourself, because you know, whatever you come up with. Definitely when you start filling out that 9 outcomes, 9 key topics, definitely there are some overlaps. Maybe one is 0, one is 0.1, one is 1, one is 0.8. The beauty of this is that unlike ABET, it's not super rigid.
So when you're in, including those EOP elements and projects at home. So how many elements do you have to put into these projects?
You don't need, so let me explain. Go through those 3 steps that I shared with you. And then you come up with something. Once you come up, you have come up, then go and fill out the 9.
But
Don't
initially-
force yourself to.
But you have these, 9 topics, these 9 categories. And then you, put just maybe 3 of those.
It's up to you, completely open, up to you.
We probably want to go for a minimum. I mean, eventually you could cover a lot, right? Small changes, right? I would say more than one homework assignment, like maybe they see, basically we're looking at outcome change. Are they gonna give a pre-survey, post-survey? How do you think you can change your opinion about some of these things? Maybe a homework and some questions on an assignment later.
Yeah, maybe I can add, to those, EOP questions at the end of the.
Maybe you can teach material, right? Like you can take 10 minutes and play some videos or sometime.
Or I can go through, some of those,
Shorten the
And
videos.
And
in your
then
class.
the semester, the post survey, and we see an improvement, we can show that to level 7,
Now, the deliverables on the side of faculty is just that the homework assignment that you have changed, that the pre and post survey, and how much weight do you put on those 9 key topics, and also the number of students that you have reached out to.
It's kind of also kind of like APEX. Because we have these outcomes that we're assessing, we influences our teaching, right? Because I'm trying to teach them about this, I would have a lecture material or something. Or it could be like self-learning, read this, read assignment. So you can kind of think about how to get them to think about these things.
I think
And
that's
then-
the whole point of this.
Yeah, exactly. And then, of course, Samir and I will be in touch with you.
Yeah, we should probably do like
What
a
question?
check in.
Yeah, exactly. Or we'll reach out to you, basically, see where you are, if you've got any questions. Whenever you've got a question about changing that course content, just reach out to us. We'll tell you. And
Do you need the student samples as well, like the sample assignments good for
Uh,
attendance?
Like APEX.
not
Like-
necessarily. No. If need,
Actually, if you, they serve as good examples for the next cohort. So maybe, if it's easy enough, okay.
maybe the
there are
good,
some samples with the assignments
so
themselves.
maybe you can keep the best. Or you,
Well, yeah.
is there a session here?
Yeah.
Interesting.
Yeah, as he told me.
Okay, so.
So some good, maybe not.
The
not-
best,
not
you,
the thing-
okay, so
just
the best
some
samples,
examples.
keep the best samples,
Okay,
keep the best samples.
sure, sir. Because we record the videos as well for the projects.
Yeah,
We
sure,
can record a video, one project poster and one report.
yeah, exactly, that's it.
Sure.
And also ask them how, those questions, so that the student will also repeat, okay, so
Okay.
this design has included these elements.
Okay.
Another question, how do you send out those surveys?
I'll tell you, it's super easy. It's easy because you can add the unique name of the students, either it can get, thank you very much.
You can link them, right?
Yeah, you can
Or
link
you
them.
can copy the questions into Canvas.
Yes, Google survey is easier because you can do live
Assessments,
statistics, yes.
yeah.
I'll tell you.
Okay.
But the very first step is to identify that homework element and see how you're going to change.
Right, I guess we're ready to conclude, right?
We're ready to conclude, but let's wait for Delian.
Oh, yeah.
But things are, I think that, so hopefully this was straightforward enough. I hope it, but just send us emails. You're out there to
It's
help.
not hard to do, you just have to think about whether it's, and stuff. When you figure it out, it's quite easy, actually.
Yeah, I mean, the whole concept is, it's not, it's pretty clear.